All right, this is the day 3 homework, and in this lesson we will be learning about the binomial distribution. All right, in order to be a binomial distribution, the variable has to satisfy these 4 conditions, okay? The first one is the observations have to fall into one of just 2 categories, which we could call success or failure. So if you're flipping a coin, that would be like heads and tails. All right, if we were talking about a test, it could be correct or incorrect, or true or false. If you're talking about children, it could be boy or girl. But what we're learning today only applies to things that come in pairs of answers. The second thing is it has to be a set number of outcomes, a set number of observations. So it can't be infinite. The n observations have to be all independent. So one outcome has to have no effect on the other outcomes. All right? Each one should be separate, independent. And finally, the probability of success, let's call it P, should be the same for each observation. For example, when you roll a die, a 6-sided number cube, the probability of rolling a 5 is 1 out of 6. The probability of rolling a 1 is 1 out of 6. The probability of rolling a 3, is 1 out of 6. The probability is the same no matter which number you're shooting for. So it has to be that type of situation. So those are the 4 conditions that must be met, and we call that the binomial setting. Okay, so looking at problem number 1, we need to decide if this has the binomial setting. When an opinion poll calls residential telephone numbers at random, only 20% of the calls reach a live person. You watch the random dialing machine make 15 calls. Okay, if X is the number of calls that reach a live person. Okay, let's see, does it have the first characteristic? Yeah, let's see, does it have just 2 categories? Yeah, it has your 2 categories. You either reach a live person or not. So that's success or failure right there. What else you got for me? Is there a fixed number of observations? Yep, 15 calls. All right, are the observations independent? Well, sure. Whether or not, if you reach a live person on call number 7, that has no impact on whether or not you're going to reach a live person on call number 8. One call has nothing to do with the other. And the last one, is the probability of success the same for all of the outcomes? And yeah, for all outcomes, the probability is 20%. So this does have the binomial distribution. And we could write our shorthand this way and say X is B. Let's see, there are 15 calls, each at probability 0.2. All right, number 2. At peak periods, 15% of attempted logins to an email service fail. Login attempts are independent, and each has the same probability of failing. Darcy logs in repeatedly until she succeeds. X is the number of login attempts that finally succeed. Okay? Yeah, this is not going to be the binomial situation. The one thing that jumps out at me is it does not satisfy condition number 2, a fixed number of observations. All right, this problem says that she just logs in repeatedly until she succeeds. All right, so there's no fixed number. Okay, there's no fixed number. So right there, that's a no. Let's see. Moving on to number 3. A student studies binomial distributions using computer-assisted instruction. After the lesson, the computer presents 10 problems. All right, so there's your constant, your set number. The student solves each problem and enters her answer. Okay. The computer gives additional instruction between problems if the answer is wrong. The count X is the number of problems that the student gets right. Okay, so it has the thing where it's either right or wrong. So it's satisfying a lot of criteria, but the one it's messing up on is item number 3. The observations are independent. Okay, knowing the result of one observation isn't supposed to tell you anything about the other observations. Okay, but this says that if you get the wrong answer, the computer gives you additional instruction. All right, so it's like they're giving you hints and things, more information, and that is going to influence how you do on the other problems. Also, the probability, it doesn't say anything about the probability. Okay, so this is going to be a no. Okay, not independent. And that's because the computer gives more instruction if you are wrong. Okay. What about number 4? You deal 10 cards from a shuffled deck and count the number X of red cards. All right, this one is a little tricky, but this is no. This is not a binomial situation. One reason is because if we're counting red cards, okay, right at the beginning, there are 52 cards in the deck. All right, half of them are red. So that means that there are 26 red cards. So there's a certain probability before you get started. But if you turn a card and you see that it is red, then right there are fewer red cards left in the deck. So the probability changes. So drawing one red card is going to affect the probabilities of drawing another red card and another red card. So because the probability is changing, or you could say each outcome is not independent. So I'm going to say both of those things. The outcomes are not independent. Okay, the probabilities are not the same. The probability does not stay the same. Okay, let's move on. Find each of the following. Now, when you have 6 over 3 like this, let me zoom in a bit. Okay, when you have 6 out of 3, like 6 over 3 like this, this means 6 choose 3. And this is a feature on your calculator. Okay, you will find it under the probability button. But first, if I want to type 6 choose 3, I have to start with 6. Then I hit the probability. See, there's my combination function, item number 2. And then I put 3. So 6 choose 3 is 20. Okay, what's next? All right, so this is 10 choose 4. Okay, so that's 210. All right, for number 7, we have 7 choose 2. All right, 7 choose 2 is 21. Okay, where is number 8? Okay, now we are going to do the actual binomial calculations. All right, so please understand, when they give you this notation, they're telling us n, all right? This is n, which is the total number of outcomes. This is the probability of success. Okay, so this is what you do. If I want to find the probability of 3 successes, because that's what this really means, then see, this is my k value. So basically, I'm using the following formula. And again, understand that this n over k is n choose k. All right, just understand that. But other than having the n choose k, we have the probability of success, and k is really the number of successes that you're shooting for, this k right here. And then this, you can think of this part as the probability of failure. All right, think of this as the probability of failure. Okay, so for example, if the probability of success is 25%, 0.25, then the probability of failure is going to be 0.75. Okay, it's the rest of the 100. Okay, now this k is the number of successes that we're shooting for. Okay, remember n is the total number, so we'll have to subtract to figure out how many failures we're going to have. Anyway, let me get back on the homework. So this is what I'm saying. The first thing you do is you're going to do start off with your total number, all right? So there's a total of 9, choose 3. Okay, because this is the number of successes that we're shooting for. So understand this. This 9 is the total number. This 3 is the number of successes. Okay, next we have to do the probability. All right, and this is the probability of success. All right, and we put a power here. Now this power is going to be 3, and it's 3 because that's the number of successes. Okay, probability of success, and here we put the number of successes. Okay, and now here we put the probability of failure. Okay, now remember, this is the total number of outcomes. If there are 3 successes, all right, which we put here, then that means there will be 6 failures. So here we put the number of successes, and here we always put the number of failures. Okay, so this is how you do this calculation. So I'm going to leave that as a guide. So again, so we have to do 9, choose 3. Now the probability of success, they told us, was 0.21. So I'll put my 0.21. And I'm going to do that to the power of 3, because that's 3 successes. Now, if 0.21 is the probability of success, then the probability of failure is 0.79. Okay? I'm getting that because if I do 1 minus 0.21, okay, I get 0.79. All right? Think of it as 100% minus 21%. Okay, that's going to be 79%. It's the rest of the percent. Whoa, I missed. Okay, now again, if the number of successes was 3, that means the number of failures will be 6 because we have a total of 9. And then we just put this in our calculator and get the answer. Okay, so here I go. I'm going to do open parentheses, 9, choose 3, close parentheses. Then I'm going to do times the probability of success to the power of the number of successes. And then I'm going to do times the probability of failure to the power of the number of failures. So there I have it. Give me 4 decimal places. 0.1891. So that would be your answer to number 8. All right, let's move on and talk about number 9. Okay, we got this inequality. When you're dealing with the inequality, you're probably going to wind up adding more than one probability. Now, remember, we know that the total number of outcomes is 9. All right, so that's the highest number possible. That's the highest possible number of successes if we had 9 successes in a row. But we also know we could have fewer successes. We could have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 successes. Okay? So the probability of getting less than 2 successes. All right, well, here's 2 successes right here. So these 2 probabilities are going to reflect the ones that are less than 2. These 2 x values are the only 2 x values that are less than 2. So I'm going to need the probability of both of those. So this is the same thing as the probability that you have. Sorry, let me just go in order. The probability of having 0 successes plus the probability of having 1 success. All right, less than 2, that's 0 and 1. If they had said less than 5, I would have done 0 plus 1 plus 2 plus 3 plus 4. All right, so I need to do this calculation twice right now. Okay, so here comes the first one. Maybe I'll do it in two separate colors. Okay, so I'm going to do this one in purple. Okay, the probability of 0 successes. So first I do 9, choose 0. And now I'll do my probability of success. So remember, that was 0.21. Now I'm shooting for 0 successes. So that means I'll give it a power of 0. Then I multiply by the probability of failure, which we remember was 0.79 from the previous problem. If there's a total of 9, these two numbers have to add up to 9. So 0 plus 9. So this will have to be a power of 9. So this will give me the first probability. And then I think I'll do the other one in pink. Okay, so the probability of 1 success. Well, we always start off with 9. So 9, choose 1. Okay, and once again, the probability of success to the power of the number of successes, right? Shooting for 1 success now. All right, and then times the probability of failure, and the power is the number of failures. If there's a total of 9, 1 success, that means 8 failures. So if I add up these two probabilities, that's going to give me the probability I was looking for. Okay, now if you want to be really slick about it, anything choose 0 is 1. And just like anything to the 0 power is 1. So look, you can feel free to type this whole thing in your calculator like this. Okay, I'm only going to do this one time to make a point. I could type in 9, choose 0, and then do times 0.21 to the 0 power, and then times 0.79. Whoa, did not mean to still be up in the exponent. Okay, let's try that again. So times 0.79 to the 9 power. Okay, if I type it all in, I get 0.1199. Let's round up. 4 decimal places. Okay, now let's go back to the calculator. So 0.1199. But if this is 1 and this is 1, then I don't really need to include them. I can just do 0.79 to the 9 power. So what if I just did 0.79 to the 9 power? Oh, look, I get the exact same answer. So watch out for those zeros. If it's a 0, that's going to be the same thing as 1, which you don't need to include at all. Okay, now let's look at the other one. Maybe I'll put it over here. Okay, so the other one is 9, choose 1. Okay, so it's going to be 9, choose 1. And then it will be times, okay, 0.21. Okay, to the 1 power, which I didn't really need to put, did I? And then times 0.79 to the 8th power. So that's 0.2867. Okay, so all we have to do is add those up. Let's see. So let's see, 0.1199 plus 0.2867. And that gives us 0.4066. Okay, so that's the answer for number 9. All right, look at number 10. It's very similar to number 9. In fact, the only difference is 10 says less than or equal to 2, whereas 9 just says less than 2. Okay, so I want the number of successes to be less than or equal to 2. Well, the only difference in my analysis, okay, looking at my list again, these are the numbers that were less than 2. If I want the numbers that are also equal to 2, I need to include the 2. So I need to do the probability of 0 plus the probability of 1 plus the probability of 2. Okay, so probability that x is 1 plus the probability, I should start with 0. Probability that x is 0 plus the probability that x equals 1, all right, plus the probability that x is 2. All right, probability of 0 successes plus the probability of 1 success plus the probability of 2 successes. That's less than or equal to 2. But of course, the first two, that's what we just did on the last problem, the probability of 0 successes and 1 success. So we got an answer of 0.4066, so let's use that, 0.4066. So all we need to do is add the probability of 2 successes. And so back to the formula. So we're going to do, remember, it's still a total of 9. That part doesn't change. Okay, n is 9 no matter what. Okay, so this is going to be, all right, why did I make the parentheses look like a C? Let me fix that, parentheses. All right, so I'm doing 9, choose. Now I want 2 successes. So 9, choose 2. Now I put my probability of success, and the power is the number of successes. And then I put my probability of failure, and here goes the number of failures. It's a total of 9, so this must be 2 successes and 7 failures. Okay, just put that in the old calculator, and there you go. Okay, so I'm going to do 9, choose 2. Okay, times the probability of success. And the power is the number of successes I'm shooting for. And then I will do the probability of failure. And the power is the number of failures. All right, these powers always have to add up to be the total, which in this case is 9. So that probability is 0.3049. All right, so now all we have to do is add that with the 0.4066 and for the total answer. So that's going to be 0.7115. Okay, so that is it for number 10. Now, why we're starting over with number 7 on the back after number 10 on the front, I don't know. But I'm going to stop the video here and just give you number 1 through 10. And I'll do the back page in a separate video. And that will have to be posted later. I will see you then.